Part 3 of our work. This is called the cubic sequence. Part 1 we did introduction to sequence, part 2 we did quadratic sequence, we did some arithmetic sequence and quadratic sequence. So in part 3 today we look at cubic sequence, and we also look at a geometric sequence. So today we round up sequence. Okay, so for cubic sequence, a sequence is only a cubic sequence if the first level difference does not have the same number, second level difference does not have the same number, third level difference, it's only in the third level that we find the same number. So when in the third level, after you find the first difference, second difference, it's only in the third difference that you find the same number. So we're going to use the comparison method using table like we did before for quadratic. We're going to use comparison method to solve the nth term of a cubic sequence. So we're going to use the table method for comparison. We're going to make two tables to find the nth term of a cubic sequence. But you have to bear in mind that the nth term of a cubic sequence is given as a to the power of a times n to the power of 3, a times n to the power of 3, plus b times n to the power of 2, b times n to the power of 2, that's bn squared, then plus c plus cn, then plus d. D is the constant. D does not have n, is the constant in this regard. Is that okay? So this is the nth term. This is the formula for calculating the nth term of a cubic sequence. You can see the highest power is 3. Okay? For quadratic sequence, remember quadratic sequence, the highest power was 2. It was an squared plus bn plus c. That was quadratic sequence. But for cubic sequence, this is the nth term. So let's take one problem and evaluate it and see how we solve a cubic sequence. Now, for example, if we say deduce the rule for the nth term of the sequence, -6, -6, find the nth term of the sequence, or deduce the rule for the nth term of the sequence, -6, right, comma, that's the first term. Then second term is -8. We have -8. And then we have -6 again. We have -6. Then we have 6. And then we have 34. Okay, this is the sequence that has been given to us. This is the sequence that has been given to us. So they want us to find the nth term of this sequence. So this sequence, if you have a sequence like this, first of all, we use the table. Like we said last time, we make a table to find the first difference, second difference, third difference. First and foremost, we're going to use a draw two table for comparison. So let's make the first table. The first table is sort of something like this, right? So we have position, we have term, and then we have first difference, second difference, third difference. Probably. Why? We're guessing this will reach up to 3 level difference. Now let's see the first case. Let's say this is our, here we have position, We have position. Remember, position is n. Then we have term. Okay, this position 1, draw here to here. This position 2, draw here to this place. This position 3, we draw for this one. This position 4, and this position 5. Okay, we draw for this one. Okay, this is the position 1, position 2, position 3. Then we fill the term in. This is -6, right? First term. Second term is -8, right? Third term is -6 again. Third term is -6 again. Then fourth term is 6, and then the fifth term is 34. Okay, so now the first work, we want to start the first task. We want to start the first task. Okay, we can easily make a table from here, right? We can easily make a table from here. Okay, now we want to start the first task. Okay. Now, let's start our first task. So we write the first difference. Let's find the first difference. So we can just write D1 to make it shorter, right? D1 means first difference, first level difference. So if we draw this line, then we find the difference. To find the difference between first term and second term, or second term and first term, then we can simply draw the line in between them here, like here. So not drawing the line down from here, because I want the difference between these two terms. So -8 minus -6, that's -8, -8 minus 6. So it will become, minus become plus. So it becomes -8 plus 6, right? -8 plus 6. So -8 plus 6 will be -2. Are we right? Here we get -2, right?
Yes.
Yeah, we get -2. Now, second difference, -6 minus 8. So the next one is -6 minus 8. Right? So it becomes -6 plus 8. That's plus 2. So here, the difference between the second term and the third term, we can put the line here. The difference is +2. It's ordinary 2. Then here, we have this and this. 6 minus 6. This 6, it's always the higher term minus the lower term. So the fourth term minus the third term. So it's 6 minus. There's a negative here. There's a minus in the formula because you have to say this minus this. So minus, and then this -6. Minus becomes plus. So it becomes 6 plus 6, which is 12. So the difference between the fourth and the fifth is what? Is 12. So we can erase this one if need be. This place. Yes, this Yungu Shuku. Eraser. Let's erase this space. This space is not. Oh my God. Okay, no problem. Okay, so I've found the difference between this. The last one, 34. The difference between 34 and 6. So you say 34 minus 6. That will be 28, right? 34 minus 6, that will be 28. So this difference is 28. So you can see the first level difference. The difference is not same. This first difference is not same. So we got to find another difference. We got to find another difference, right? So we call it D2. We find another difference. We call it D2. So that's the difference between this and this now. The difference between this and this will be what? 2 minus minus 2, that's 4. Am I right? 2 minus minus 2, that will give us 4. This 2 minus this one, that's 4. That's minus minus is plus, so we get 4 here. Then the difference between this and this, 12 minus 2, the difference between these two terms, 12 minus 2 is 10. So we have 10 here. Then the difference between 28 and 12, 28 minus 12. So you can simply do that, 28, 12, right? That will be 16, right? This minus this, you get 6. This minus this, you get 1. So this here, we get 16. You can see that after doing the second difference, you did not get the same number. You know we have to arrive at the same number. So we have to do a third difference. That's why this is cubic. If you are doing up to 2, it's quadratic. If you do up to 2 level difference, it's quadratic. If by this level you get the same number, then this will be called quadratic. But if you have to do up to 3 levels for you to get the same number, then this one will be regarded as cubic. This will be regarded as a cubic. So let's find the difference between this one and this, 10 and 4. The difference between 10, that's 10 minus 4 is 6. And then the difference between 16 minus 10 will also be 6. So you can see now we have arrived at the same number. Now we have arrived at the same number. So since they are same, it took us 3 levels to have the same number. So this is what we call the cubic. Once in the 3rd level you get the same number, then we call this the cubic. Now what we're going to do, we're going to make another table to compare with this first table. And then we find our A. Remember, these are our coefficients. We're going to find A, find B, and find C, and find D. Then we substitute back into this formula the values of A, B, C, and D, and that will be the end term. We're going to find A, B, C, D, and substitute it back here, and then that will be the end term. Now let's draw another table for comparison, a table that will help us to be able to compare. A table that will help us to be able to compare. Take this one. Let's. Okay. Why did you erase? Because we need to make the table big. So this table, let's give it a chance to be big. Because we're going to be entry A, B, C, D. Remember, right? When we did for quadratic, we're going to be entry those A, B, C, D, E, F. A, B, C, D. We're going to be entry them here, and it's a lot. So this table needs to be big. Okay. Okay, here will be for first level difference, here will be for second level difference, and the last one will be for third level difference. Okay, let's write with maybe pink or blue. We've used blue. Let's write with red this time around. Okay, now here we have position. As usual, position. We have position. Here we have term. Okay, here is D1. first level difference. Here is D2, second level difference. Here is D3, third level difference. Okay, let's, for position 1, here is 1. Here is 1, right? Here is 2. Here is 3. Here is 4. And here is 5. So let's find the first term in regards to when n is 1. When n is 1. Remember the formula? Remember the formula? an raised to the power 3 plus bn raised to the power 2 plus cn plus d. So if n is 1, remember this place is called n. This position is called n. So if n is 1, 1 to the power of 3 is 1. 1 times a is a. So here I will have a plus, if here is 1, 1 square is 1. 1 times b, I will have plus b. If here is 1, 1 times c, I will have plus c. And if here is d, there's no n there, so you just say plus d. So the first place, I just have a plus b plus c plus d. Now the second place, n is 2. Here, n is 2. Since n is 2, you got to substitute 2 here in place of n. 2 to the power of 3 is 8. That's 2 times 2 times 2. 2 times 2 is 4 times another 2 is 8. So 2 to the power of 3 is 8. 8 times a is called 8a. So here we have 8a plus, here n is 2. 2 square, 2 to the power of 2 is 4. 4 times b is 4b. So here we have plus 4b plus 4b. Then here n is 2. 2 times c, we have plus 2c plus 2c. Then plus d. Plus d. Then here n is 3. 3 to the power of 3 is 27. So here we have 27. 27a, right? We have 27a. Then plus 3 square. Look at here. We're using this formula. 3 square is 9. 9 times b is 9b. So plus 9b. There, 3 times c is 3c. So we say plus 3c. Plus 3c, there plus d. Here, n is 4. 4 to the power of 3, that's 4 times 4 times 4, that's 64. Right? So here I have 64a plus, now n is 4. 4 square is 16. 16b. So plus 16b. N is 4. 4 times c is 4c. So plus 4c. Then plus d. Then here n is 5. 5 to the power of 3. That's 5 times 5 times 5. That's 125. So here we write 125a plus 5. 5 square, that's 25, plus 25b plus 25b plus 5 times c is 5c plus 5c plus d. So we've got the terms, okay? We've got the terms. Now we're going to do subtraction, the difference, first level difference. So we're going to find the first difference. We're going to find the first difference between them. So we're going to find the difference between this and this, the difference between this and this, the difference between this and this, and then the difference between this and this. We're going to find their first level difference. Now the first level difference is to say 8a minus a, that's 7a, right? So here we get 7a. We get 7a quickly. Here we get 7a, because 8a minus a, we get 7a. Then 4b minus b, we get what? We get 3b. So you say plus 3b. And then here you say 2c minus c, you get c. You get plus c. You say plus c. D minus d is 0. D minus d is 0. So there's no need to write 0 here. Then here we find the difference again. 27a minus 8a, what do you get? 27a minus 8a, that's 19, right? So you get 19a here. 19a plus 9b minus 4b, that's 5b, right? So you say plus 5b, plus 5b, and then 3c minus 2c, that's plus c. D minus d is 0, so no need to write d. Now here we find the next difference. We're going to say 64a minus 27a. 64a minus 27a, we're going to get 37a, right? So here you get 37a. 60b minus 9b. 16 minus 9, that's 7, right? So we say plus 7b. 4c minus 3c, you get plus c. D minus d is 0, so no need for that value. Then the next one is 125a minus 64a. This 125 minus 64. 125 minus 64, I think you will get 61. 61a, okay, plus 25b minus 16b. 25 minus 16, that's 9, right? You say plus 9b, plus 9b. 5c minus 4c, you get c. Say plus c. D minus d is 0, so no need for that. So we found our first difference. You can see it's not also same, just like the way first difference here was not same. So also this comparison table shows that they are not same. Now we're going to move to second level. We're going to move to second level difference. Now in doing that, we're going to have compare this one with this minus this minus this, and then this one minus this one. Now let's take a look. Let's fill it up. Let's do it and fill it up. Let's do it quickly and fill it up. Okay. Now let's take a look at 19a minus 7a. 19a minus 7, what do you get? 19 minus 7, you get 12. So we get 12a. So we got 12a. 19 minus 7 is 12. We get 12a. 5b minus 3b. 5b minus 3b, you get 2b. So we get 2b. C minus c is 0. C minus c, this c minus this c is 0. So yeah, you don't need to write 0. Now we move to this one. 37 minus 37a minus 19a. 37a minus 19a. I think we get 18, right? So we get 18a. We get 18a. And then we'll say 7b minus 5b, we get 2b. We say 80a plus 2b. C minus c is also 0. So no need to write that. This c minus this c, you get 0. Now we go to the last phase for this roll. For this roll. So we say 61 61A minus this 61A minus this 37A. So we get 61A minus 37, we get 24A, right? So here we have 24A. And then 9B minus 7B, you get C2B. C minus C is 0. This C minus this C, it gives 0. So no need to write 0. You see, in second level, they are not same. So we migrate to third level. We migrate to third level. So let's find the difference at the third level stage. Let's find the difference at the third level stage. Now the difference between this one and this one, the difference between this and this, that's what we're looking for now. So we draw one here. Now let's find that difference squarely. Let's find that difference squarely. The difference between this and this. Let's use orange now. Now we say 18A minus 12A. 18A, this 18A minus this 12A. You get 6A. Right? You get 6A. You get 6A. Now you see 2B minus 2B, 2B minus 2B, you get 0. So no need to write that. Then you come here, the difference between the third, this one and this one. So 24A minus 18A, you also get 6A. You also get 6A. 2B minus 2B, you get 0. So you can see at the third level, they are same. Now to solve this problem, to find A, B, C, D, is to compare these two tables. Exact position to exact position. So we're going to compare this one. We're going to compare this exact position with its corresponding exact position. So we're going to compare this exact position, 6A, with its corresponding exact position on table A. Okay, this is table B and this is table A. Okay, or table 1, table 2. So we're going to compare the exact position of table 1 with exact position of table 2. So by doing so, we equate them. We say they are equal because they are at the same location. So we say 6A is equal to 6. Right? This 6A will be equal to what? It's equivalent here. Equal to 6. Equal to 6. So if 6A equal to 6, now A will be what? Meaning you divide both sides by 6. A will be 6 divided by 6. Because they be multiplied. So to find it, you have to divide. So you say 6 over 6, which is equal to 1. Which is equal to 1. So A equal to 1. Keep note of that. We're going to find A, B, C, D. Now, the next step is to compare this one. The next step is to compare this location, this one. Is to compare this one with its exact location on D2 for table 1. Exact location on table 1, which is 4. So we're going to equate 12A plus 2B equal to 4. So let's do that. So we say 12A plus 2B, we say equal to 4. We say this is equal to 4. Now, remember we found A already. A is 1. So we're going to substitute that value here. So we say 12 times 1, 12 times 1, plus 2B is equal to 4. So 12 times 1 is 12. So we say 12 plus 2B is equal to 4. So 2B will be 4 minus 12. 4, we bring this one this way. It becomes 4 minus 12. Right? Then B, that's 2B, will be equal to negative 8. Right? Negative 8. 4 minus 12 is negative 8. So we have negative 8. Now we say B, you divide both sides by 2. Right? B will be equal to negative 8 divided by 2. Negative 8 over 2. So B will be equal to what? Negative 4. So take note of that. We found B, we found A, we found B. Now let's find C. To find C, we're going to equate this location. We're going to equate this location. Let's use something different. we're going to equate this location. 7a plus 3b plus c, we're going to equate it with the exact location here, equal to -2. Equal to -2. So we're going to do that. 7a. So 7a, let's write with a bright, okay, let's use this orange. 7a plus what? Plus how many b? Plus 3b plus c. 7a plus 3b plus c is equal to what? I think it was -2 in table 1. -2, equal to -2, -2, equal to -2. So we write here. So remember, we know the value of a is 1. 1 times 7, we just write 7 here. Because a is 1. 1 multiplied by 7, we get 7. B is -4. B is -4. Look at it here. B has been obtained to be -4. So you say -4 multiplied by 3, multiplied by +3, you're going to get -12, right? So I write -12 here. Then plus C is equal to -2. Now we're going to find C now. Okay? 7 minus 12 will be what? -5, right? -5. So here we have -5 plus C is equal to, plus C is equal to -2. So C will be what? Will be equal to -2. If you move -5 from the left side to the right side, it's going to be +5. So it becomes +5. -2 +5, C will be 3. C will be equal to -2 +5 is 3. It's like you're owing someone $2, and maybe your dad gives you $5. If you pay, you still have $3 left. So equal to +3. We found C. Now we're going to find D, the remaining one, the remaining coefficient or constant. D is a constant. So A plus B plus C plus D is equal to what? -6. Is equal to this location. Okay, this location is equal to this location on the corresponding tables. So A plus B plus C, A plus B plus C plus D equal to -6, right? Equal to -6. So let's write that one here. A plus B plus C plus D is equal to -6. Okay, so A is what? 1. B is what? -4. So negative and plus, it will be negative. -4. C is what? 3. So plus 3. D we don't know. That's what we're looking for. We're looking for D plus D equal to -6. Equal to -6. So we have 1 minus 4, that's -3. -3 plus 3, that's 0. So we only have D left here. So D is equal to -6. D is equal to -6. Okay, are you with me? So have we found all the coefficient and the constant A, B, C, and D? Remember your n term. Before we write it, let's refresh our the way it is. The n term is what? An to the power of 3 for cubic sequence. An to the power of 3 plus Bn to the power of 2 plus Cn plus D. This is the formula for writing the cubic sequence. Now we found our A, B, C, D. We just substitute. So the n term of this sequence is simply A is what? 1. So no need to write 1. So you just write n to the power of 3. 1 times n to the power of 3 is same as n to the power of 3. Then B is -4, right? B was -4. So you write minus 4n squared minus 4n squared. This n squared. Put it minus 4n squared. Then plus C was what? 3. So plus 3n. Only this Only this ABCD you replace. A, B, C, and D you replace. Plus 3n. And then D was what? Negative 6. So you say minus 6. So this is your n term. This is your n term. Is that okay? This is your n term. This is your n term. This one. This is the n term of the sequence, of the cubic sequence. So if you want to do it trial by error, you will waste a lot of time to be able to obtain this type of sequence. So that's why this method is very appropriate for, though it's a bit time consuming, but it's worth it. At the end of the day, it's worth it. Okay? So next one is the exponential sequence, or what you call the geometric sequence. So let's quickly take a look at, we want to round that one up today, what you call exponential or geometric sequence. Exponential or geometric sequence. Exponential or geometric sequence. Exponential or geometric sequence. Now, when we have exponential or geometric sequence, this one can be used in applications like in compound interest and so on and so forth. But before we get there, let's first of all identify a sequence that will be considered a geometric or exponential sequence. For example, if we give a sequence 2, 4, 8, 16, 32, 64, okay? Now, what makes it a geometric sequence? It means it's a multiplicative or divisive sequence. So, meaning to get the next term, if you give it the first term, to get the next term, you're going to multiply this one by 2. So, you multiply this one times 2. The first term multiplied by 2, you get the second term. Okay, you get 4. 2 multiplied by 2, you get this. To get the third term, you say the second term multiplied by 2 as well. So we multiply this one by 2. So you can see the sequence is progressive by multiplication or by division in case the numbers are descending. If the numbers are descending, then it will be by division. But if the numbers are ascending, then it's by multiplication. So 8 multiplied by 2, also you will get 16. So the common ratio, it's a ratio. It's not a difference. It's a ratio. We're going to show you. Because to get this one, you say this divided by this is a ratio. To get the common, this one, you say 4 divided by 2 is a ratio. Division is a ratio. Is that okay? So to get this one, you say this multiplied by 2, you get this. So we don't call it a common difference. This is not a difference. It's a ratio. So we call it common ratio, R. Common ratio. Common ratio, R. So the n term of this type of sequence, the n term is given as, assuming A is our first term, A R into n minus 1 raised to power n minus 1. Okay, this is the n term for finding this type of sequence. Meaning, if I ask you to find the n term of this sequence, this will be, the first term is A equal to first term. A, in this regard, in this formula, A equals to the first term. First term. So, if that is so, and then the common ratio is 2. A is 2, common ratio is 2. So if you ask to find the n term of this sequence, the n term will be 2 multiplied by 2 or 2.2, then n minus 1, raised to power n minus 1. So this will be the nth term for this sequence, right? This will be the nth term of this sequence. This will be the nth term of this sequence. So for geometric sequence, it's also easy. Let's say another example. If you give you 3, let's say this example 1, this example 2. Okay, if you give it 3, 6, 12, 24, 48. Okay, this you can see is progressive by multiplication of 2. 3 multiplied by 2, you get 6. 6 multiplied by 2, you get 12. 12 multiplied by 2, you get 24. 24 multiplied by 2, you get 48. So you can see the progression. Progression is a multiplicative case, being multiplied. Okay. Okay, so the first term will be 3 in this case. The first term will be 3. Second term will be 3 multiplied by the common ratio. That's first term is A. Second term will be what? AR. Because why? Second term is because n will be 2. You know the formula is AR n minus 1. Okay, so n is 2. For second term, n is 2. For first term, okay, why is first term just ordinary A? Okay, for first term, n minus 1, right? N is 1. 1 minus 1 is 0. If you are saying first term, n is 1. 1 minus 1 is 0. So r raised to power 0 is 1. 1 times A is A. That's why first term is simply A. First term is A. And the second term, n is 2. 2 minus 1 is what? For second term, 2 minus 1 is 1. So for second term, it will be A arrow. A arrow. A arrow raised to power 1, which is same thing as A arrow. For third term, using this, for third term, it will be what? N is 3. 3 minus 1 is 2. So we have third term to be A arrow raised to power 2, right? 3 minus 1 is 2, raised to power 2. For fourth term, you know the formula is this A arrow n minus 1, right? Raised to power n minus 1. For fourth term, so 4 minus 1 is what? 3. So you have this is equal to A arrow raised to power 3 for fourth term. This is fourth. This is third. This is second. This is first. Okay, for fifth term of this geometric sequence, it will be the formula is A arrow raised to power n minus 1, right? For the n term. So for fifth term, n is 5. So you say 5 minus 1, that's 4. So you have A arrow raised to power 4. So if you want to find a term in the fifth term, what you just do, the first term is what? 3. So first term is 3. So if I'm looking for 1, 2, 3, 4, 5, right? You see how it's 48 now. For fifth term, you see first term is 3. The formula is what for fifth term? Formula is what? A arrow raised to power 4. Right? Which is equal to A is 3. The common ratio is what? 6 divided by 3, that's 2. Common ratio is 2. So you say multiply by 2 to the power of what? 4. 2 to the power of 4. So 2 to the power of 4 is what? 2 times 2 times, that's 16. 16. So you say 3 times 16 is what? 3 times 16. That will give us 48. Is that okay? So if you are asked to find the 10th term, let's jump to the 10th term. Okay, if you are asked to find the 10th term of this geometric sequence, you know the formula is A arrow n raised to power n minus 1. Since it's 10th term, it will be n is 10. 10 minus 1. So 9. So we have a arrow to the power of 9. Right? Now if we want to evaluate it, then we will say 3 times 2, common ratio is 2. 2 to the power of what? 9. 2 to the power of 9 is what? Can someone evaluate? 2 to the power of 9 is what? Quickly, what do you get? That's 2 times 2 times 2 times. 2 to the power of 5 is 32. 2 to the power of 6 is 64. 2 to the power of 7 is 128. 2 to the power of 8 is 256. 2 to the power of 9 is 512. Yeah. So 2 to the power of 9 is 512. Multiply that number by 3. 5, 1. So this becomes 3 times 512. 3 times 512. This gives you 1,536. Okay, this is your 10th term of this geometric sequence. This is your 10th term of this geometric sequence. Is that okay? If you are asked to find the 10th term, if you're looking for the 10th term of this geometric sequence, it will give you this value. Is that okay? So it's easy to apply. It's easy to apply. Is that okay? Now we can apply this sequence for money in the bank, compound interest, and all lot of you. For example, if you say $100 is deposited in a bank account and left untouched, $100 is deposited in a bank account and is left untouched. After 1 year, the amount has increased to 110 as a result of interest payment to this account. So you have to work out this. You have to find the increment, and after you can determine after 5 years how much you will get. Okay, this will be expounded. Will be applied using geometric sequence. So after 1 year, you get 110. So to find the common ratio, because the first term is what? 100. The second term is 110. So to find the common ratio, you will say this divided by this, right? The second divided by the first. So you say 110 divided by 100, that gives you 1.1. So 1.1 is the common ratio. 1.1 is the common ratio. Since 1.1 is the common ratio, your first year you get $100 for the money you invested. Your second year you must multiply now by 1.1. You must multiply by 1.1. So if I multiply here by 1.1, 100 times 1.1, we will get 110, right? Then for your third year, you will multiply again by 1.1 to get the total amount for your third year. So you say multiply by 1.1. 110 multiplied by 1.1. 110 multiplied by 1.1. That will give you 121. So it will give you third year, you get 121. Then multiplying the third year with the common ratio, same common ratio, you get the money for the fourth year. So meaning multiplying it with 1.1, 121 times 1.1, then we will get 133.1. We get 133.10. This is the money we get for our fourth year. Now if you want how much you get for fifth year, you still multiply this amount, 133.10 cents, multiply it by your common ratio, which is 1.1. You will get the money for the fifth year, which is 146.41. You get the money for the fifth year, 146.41. Now, if you want money for the sixth year, how much you get in your bank account, if you keep this money, then you will multiply it again with the common ratio, which is 1.1. So 146 times 1.1 will get the money for the seventh year, right? or the 6th year. So we get 161.05. Okay, this is the money we get. Now, since this was the money that we borrowed or we deposited in the bank, this is going to be like the 0 year. This is not the first year. So first year we start from here. First year we start from here. First year, second year, third year, fourth year, and this will be our 5th year. So if they ask you how much you're going to earn in that amount for after 5 years, this is the amount that you're going to earn for after 5 years. Remember, this is not the first year. This is just the money you deposited. Okay, it was from here to here that led to 1 year. Remember that. Here to here 1 year, here to here 2 years, here to here 3rd year, here to here 4th year, here to here 5th year. So after 5 years, this you're going to smile with this amount. If you deposit this amount of money, you're going to go home with this $161.05. That's what you're going to go home with. Is that okay? So this is how we use the compound interest, how we use the geometric sequence, how we apply it to compound interest. Is that okay? So this is the end of our sequence for Waitam Academy. Subscribe to our channel. Next class, we're going to go to variation. We're going to do variation. Is that okay? Thank you.